Good afternoon. Today I'm going to be talking to you about a very exciting new advancement in information technology, which will allow thousands of Australians living with vision disabilities and illnesses to be able to recognize light, shapes, and objects. This new technology is called the Bionic Vision System. What makes this device so revolutionary is the fact that it provides a greater field of view than previous versions of the bionic eye. Advances in technology, such as minimizing the size of computer chips and bioengineering, are laying the groundwork for new devices that can play the role of important organs within the human body, such as the eye, or at least to help them function better. How does it work? The Bionic Vision System consists of a camera attached to a pair of glasses, which transmits high-frequency radio signals to a microchip implanted in the eye. Electrodes on the implanted chip convert these signals into electrical impulses to stimulate cells in the retina that connect to the optic nerve. These impulses are then passed down along the optic nerve to the vision processing center of the brain, where they are then interpreted into images. Who will it help? This technology is designed to help people with severe vision loss due to retinitis pigmentosa, as well as age-related macular degeneration. The images here are examples of what people with unimpaired vision, glaucoma, and macular degeneration might see. This device is said to have the potential to restore sight to 85% of the clinically blind in Australia. By being able to have some sight restored to an individual suffering from clinical blindness is a very big deal. It would allow an individual to become more independent, less reliant on visual aids such as guide dogs and canes. Being more independent will also mean that individuals' self-esteem is increased, which leads to an overall happier outlook on life. Recent advancements in technology. With researchers continually searching for ways to improve the vision quality of the bionic eye, in 2009, the Australian Research Council funded a new collaborative research initiative to develop a functional bionic eye. The Australian government committed funding of $50 million over 4 years. 2 research teams were chosen to share this award: the Monash Vision Group and Bionic Vision Australia. The Monash Vision Group has been working on a new design called the Generis Direct-to-Brain Bionic Vision. Which enables the device to be implanted directly onto the visual cortex of the brain. This new approach bypasses the retina and optic nerve, making the Monash Vision Group device suitable for people with vision loss due to a wider range of illnesses. Continued testing within this year has seen the device being implanted in the first patient, and clinical trials have begun. The Monash Vision Group aims to provide cutting-edge biomedical material that is safe, advanced digital processing technology, and wireless transmission to reduce infection and more advanced microchips. Finally, to sum up, I feel this is a very important advancement in technology which allows for further advancements within the biomedical field. The Monash Vision Group have been working on a new device which includes a chip which is implanted directly into the visual cortex of the brain, is much smaller and able to hold more data. This means that users can identify a larger variety of objects and increase their range of vision, to include the recognition of faces and large prints even. The bionic eye is one example of how technology has improved the quality of life for the clinically blind, by allowing an increased level of independence and self-esteem due to the fact that they are able to trust and rely on their own sight senses. Further testing and evaluations will lead to a better quality product, which will offer a higher field of vision, and maybe even a smaller device with a range of designs to appeal to changing preferences. Thank you for taking the time to listen to my presentation.